Okay, students, now let's move on to solid waste containment. That's on how landfills being designed. We saw earlier on that if your landfills are not properly lined, not properly designed, then you could have a possibility of leachate coming out, coming through the unsaturated zone, or exceeding the infiltration capacity of the unsaturated grounds, and causing the leachate to go through to the saturated zone and join the groundwater. Once it joins the groundwater, then we are in trouble, because the groundwater flows from all the four methods that we have, four processes that we have talked about, effective and so on, and it will reach far and wide. Okay, like a balloon. Remember I told you the plume will expand and expand. It goes very far and very wide, and it could be contaminating not just our soil, it could be contaminating our water as well. Right? So how are these solid waste disposal facilities being designed? Basically, there are 7 components here, and it's important to know. See this little symbol here? Good. Okay, just in case when you go for your LI, or when you graduate, you may be working with these, for example, can't remember the SWM, is it? The Southern Waste Management, yeah, for example, these privatized companies that take care of solid waste, so it will be good to know, right? Okay, so the first component is the liner system at the base and also the sides of the landfill. So basically, you excavate into the ground, and before you start dumping your waste into it, you got to start lining it. And these liners are usually what we call the membranes, geomembranes. And if you recall from our geosynthetic talks, and you look through some of the products, these liners are actually essentially 2 layers of geotextile, so water could go through, but inside is a layer of this expandable kind of clay, usually marmorillonite. So once the leachate, which is in liquid form, goes into the liner, it will cause the clay to expand and seal out all the pores in there. So theoretically, none of the leachate, none of the liquid could actually puncture that layer into the ground beneath. But everything has got a lifespan. Over time, this clay will harden, and when you put more rubbish on top of it and you start compacting it, this hardened layer of clay could actually crack, and when it cracks, then the leachate will start to come through. And this is actually a very common problem in landfills, where the liners are not being properly installed or not being properly monitored. Okay, so there's a liner system, and we'll have a leachate collection arrangement at the base of it as well. You'll see later on that it could be in the liner, above the liner, and beneath the liner, as in a double leachate collection system, things like that. But it must have a leachate collection system in place. All right. And the third component is a cover system. Across the top of it, remember the first few slides we saw the beautiful landfill, the completed landfill that we saw in Belgium and in Georgia in the States. There's a nice covering, whether either you cover it with high-strength polyurethane so that no water will actually go in and cause more leachate to be produced, more toxic juice to be produced, or you have nice turfings and all covered with soil and all, so that and turfings, vegetation, so that the surface runoff, precipitation coming from water, rain and all, will not excessively infiltrate into the landfill and cause more juice to be produced, the leachates. Alright, we have the gas collection system. Remember, most of these waste were dumped in a landfill are actually biodegradable, and we know that when things are being biodegraded by the microbes, then we have biogases coming out. One of the most common one is actually methane. And methane, if you don't contain it carefully, it just oozes out from the ground. Someone starts a fire there, like lighting a cigarette, you could actually get blown up. Okay, hence it's important to collect them nicely and store it away. It can be used. I say methane is a fuel. Okay, if you recall the two example landfills that we had, the well-managed landfills, they have this methane gas collection system where the gases are being used as fuel for heating and all. Okay, and surface water drainage system, the surface of it, whether you have a proper liner covering it or you have a turfing system and all, you need to have surface drainage, longkang longkang and parade to drain away the rainwater. Especially in places like us with monsoons and all, we have a lot of rain, then we got to make sure that the surface runoff is being taken care of. Number 6 is an environmental monitoring system. Remember, we talked about putting in the gas and also groundwater monitoring wells, basically poking these pipes in there, and to make sure that you can always take out the water samples and also monitor the gas that is escaping from the landfill. Alright, and last but not least is what we call the post-closure plan. This is not a thing, this is a plan, a management plan, because every landfill will come to is being designated to carry a certain amount of rubbish, if you like. One is you put in the rubbish, you put the soil, you compact rubbish, soil, you compact layers by layers. So eventually it's like the hole is being covered up again, filled up again. Once it's filled up, then it's done. So what do you do with the ground? You reuse the ground actually. So how to make sure that it's being reused properly? You have to have a post-closure plan. And usually you do not just cover it up and sell the land to people and start building houses. When you do piling and puncture the liner and let the leachate, the toxic juice leak out, no. These places are usually carefully monitored and contained for many, many years to come. Alright, so this is about the post-closure plan. Alright, so those are the 7 components. And some examples here are how properly managed sanitary landfill, that's what I call sanitary landfill, will look like. As you can see here, essentially you need this lining system, remember, liner on the side, on the base, leachate collection system, methane recovery, there's a gas collection, you have monitoring wells, and the top you have the cover, okay? And the leachate, usually we have it taken out into a leachate collection pond and they're being treated before they are being thrown out into the normal discharge waterways like our drains and what we call the parades. From the parades, the canals, they will go on to the rivers and so on, remember, and you suck it up to the water treatment plant and use it again. So be very careful of what you dump, what is coming out from these landfills. In a more idealized way, as you can see, first and foremost, you notice that yes, the monitoring wells are more organized. You have the ones that are going down to above the groundwater table, and there's one that's going down below the groundwater table. So these will be taking care of the water quality in the unsaturated zone, and these are the ones that goes into the saturated zone. Okay, and look at the more complex design that they have. These liner coming in, and you have the leachate collection that is actually at the base of it and also inside. Okay, so it's a double protection system. Okay, and some other examples here, hazardous waste. Remember we talk about this, for example, radioactive materials or very highly toxic stuff. So you put in containers and they dump it underground. Usually these are very, very carefully designed and done. You can see impermeable caps, so water runoff, rainwater cannot be entering it. And you have monitoring wells, you have leachate collection and all. These are the toxic waste that you can you can find in these kind of special landfills. And another picture show it. This is a more carefully designed one. You have some you can see here gas vent, right, to let the gas escape, gases escape. You have leak detection system to make sure that there's nothing unfavorable coming out of it that we don't know, double leachate collection system, and so on and so forth. Okay, you can look for more of these examples of the real world, alright, on Google if you like, to see how they actually look like. What we saw earlier on, the schematic diagram, is just a basic, the essentials of what the landfill will need. Now, I would like you to look at this, the Fukuoka method. This is an innovative landfill. Look at this. You recall that a lot of these, the landfill is actually confined and contained, meaning that there's not much oxygen in there. So anything, any biodegradation process going on in there would be anaerobic. You remember that? Anaerobic. Anaerobic means without oxygen or with very little oxygen. But in Fukuoka's method, we are talking about letting oxygen go in through where? The end of your leachate pipe is actually always open to the air. So oxygen go in, and when oxygen goes into the waste, then the bacteria will be able to conduct aerobic degradation process. Apparently, aerobic could be more effective in this case, and so it would release CO2, that's carbon dioxide, and the leachate that's coming out will be less toxic because the biodegradation is more complete. Alright, and so that it's found that this method causes less odor, less smelly, cleaner leachate, and there's less methane emission. So you can read up a bit more about this if you like. It's very interesting actually. It's very innovative, and some landfills around the world has adopted the method. Okay, right. Next we'll look at slurry transported waste. Remember, all this while until now we have been looking at solid waste, alright? But waste could come in liquid form as well. Like in this case, it's half solid and half liquid. So what is slurry actually? They're actually powdery material, alright? Powdery material like silk to sand size, they're fine, but not as fine as clay. So you can't just throw them out like this from factories. What do? Because if you throw them out like this, the wind will bring them all over the place, and then the Department of Environment could come and sue or to issue summon to these factories. So they usually put it into the pond, slurry pond, where they mix up with water. So it's like 6 to 10 parts of water to 1 part of solid. So you can imagine it's like a semi-solid kind of material. All right. So how do you transport this from the plant to the disposal site? And the most popular method would be through pipelines. Okay, and these are the sizes that they're talking about, and it's convenient and more economical because you could take them out in large quantities, and quite safe on condition that the pipes are not leaking and well maintained, compared to using trucks. Right, if you're using trucks, there are many trucks will be coming in and out, so you have to rent the trucks, prepare the trucks, you have to pay for the fuel, and these are all cost savings. You're using pipelines. All right, so bear in mind why we use pipelines for slurry waste. And these impoundments, or the ponds that we use to contain slurry waste, there are several types. The ring type, so obviously as the name implies, it is on 4 sides being raised embankment to contain the slurry waste. It's like making a pond essentially, right? By raising it on the ground level. So you raise a little bit, you pop in your slurry. As it fills up, you raise the side of it. So eventually you have like a little above ground containment structure. If you can have a side hill one, so these are contour lines, right? So if it's a side hill, so of course you contain on the downhill side. Or it could be a cross valley type, so on both sides. So it's like on the 2 lower ends they are being contained. So this is it's just an example of how this containment could look like. And in terms of the operations of these slurry waste containment facilities, it's not just excavating a hole and dump the slurry there. No, similarly like our landfills, it got to be properly managed and properly instrumented. So you can look at this. The plan view and the side view of example of a slurry waste containment situation. So let's look at an enlarged section of it. So this is the infill. You can see there is the slurry being pumped into your containment, the impoundment or the containment pond. So, and remember, because it's part solid and part liquid, you actually form beach. The nearest beach name. Beach will tell you it's still in damp form. It's not. It's semi-wet and all, and it has a gradient. So the solid beach will be settling around here, and it slowly goes down to the gradient. And here you have more water. All right, and the water will be slowly decanted, meaning that they are being taken out. So slowly these will form a solid base. And they will be taken out to be dumped with treatment and things like that. So you notice that the top of this slurry pond will always be covered with a thin layer of water. Why? Simply because you do not want it to dry up and the powdery stuff to be taken up by the wind and start contaminating the atmosphere. Alright? Okay, then we move on to about how do we deal with the contaminated site if we come across one. Okay, you have 2 major options. One, you move your site to a new engineered site. Maybe this site is contaminated. Let's move the whole lot to a different place. But this is costly. So normally what we do is that we try to control the movement of the contaminants. Okay, and to control it, then we start setting up barriers. We'll look at this in the next part of the slide. All right.